Hello students, good morning everyone. I hope you are getting my voice clearly. Yeah, so in this session, let us continue the mathematical physics or basic mathematics in physics part 2. In the previous session, we have discussed a few points related to trigonometry. Let us just a couple of minutes, let us glance at it. Yeah, see here. The previous session we have, as part of trigonometry, we have discussed what is angle. So angle is nothing but the amount of revolution that a revolving line makes with its initial position. As in the figure, I have discussed this. And we have also discussed about units and dimensions of the angle. Plane, actually we can call it as it is actually a plane angle, but simply we call it as angle. It is one of the quantities in SI system, supplementary quantity we can call it as. So SI unit of angle is a radian denoted by rad. SI unit of SI unit of angle is radian denoted by rad. And dimensional formula, it is a dimensionless quantity. It is a physical quantity but no dimensions. Right. So another unit we use to measure the angle is a degree. Another unit we use to measure the angle is a degree. Another unit is degree. Another unit of angle is degree, denoted by like a whole symbol, like it is like 30 degree, 90 degree, like this. Okay, example. So like denoted by like this, degree. Yeah, okay. And when the angle measured is taken as positive and negative, when the angle will be taken as positive when the rotating line is tracing in anti-clockwise direction, and it is taken as negative when it is tracing in clockwise direction. So angle is taken as negative if it is covered in in clockwise direction, positive when it is covered or traced in anti-clockwise direction. Got it? And we have also discussed briefly about 1 degree is equal to 60 minutes. This kind of points we have to use while doing the numericals. We have to remember it. Okay, 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds, and one right angle is equal to 90 degree or pi by 2 radian. And definition of radian we have discussed, and one radian, and what is the relation between a radian and a degree also have discussed. One radian is equal to 57.3 degrees, and the conversion relation, how to convert angle from degrees to radian and radians to degrees. To convert an angle from radian to degree, we have to multiply the given angle in radian with 180 by pi. With 180 by pi. To convert angle from radian to degree. From radian to degree. Okay, whereas we have to multiply with 180 by pi. Whereas to convert an angle from degree to radian, we have to multiply the given angle by pi by 180. This based on this we did a few examples also. I hope you guys have remembered these points. Now let us see, let us continue with a few more additional points. And here we have also discussed one of this question also. Okay, I hope you have understood this. Now let me discuss one more example related to this, then let us get into another related concept. Let me check 1 second guys, let me check whether the live is streaming or not. So the live, where is the live? It's going on. Yeah, but Is it coming properly or not? One second, guys. One second. Let me check whether the live streaming is coming properly or not. Actually, in this session, we are going to discuss trigonometry 2, second part of trigonometry. Trigonometry 2. Trigonometry 2. So that is continuation of trigonometry. Continuation of trigonometry. Yeah. What is that? Yes. So let me give you one simple example which relates with the previous conceptual discussion. Then let us get into the remaining part of trigonometry. So note down one simple question here. A question. The question is, when a clock shows 3 o'clock, when a clock shows 3 o'clock, when a clock shows 3 o'clock, how much angle how much angle how much angle do its minutes hand how much angle do its minutes sorry yeah how much angle do its minutes hand and our needle and our needle makes is the question. So you have to understand the concept clearly, guys. You have to understand the concept clearly. If you draw the pictorial representation of this, then only you can work out this kind of questions. So this kind of questions you may come in different while dealing with numericals of different chapters in electric charges and fields, in gravitation, and some other related chapters also you may come across. So how to deal with this? Let us see. So let us try to draw the what is this actually? When the clock shows 3 o'clock, means you have to consider that you have to imagine a wall clock. Wall clock. This is a wall clock. Let us imagine this is a wall clock, and let us say it is in the form of course circular shape. It is identical to circle. The total angle subtending by the circle at the center is 360 degrees, semicircle 180 degrees, and one quadrant subtends 90 degrees. But in a clock, we have to mark the timings as this is 12, 1, 2, says 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So now the question, if you go to the question carefully, what is given in the question is, when a clock shows 3 o'clock, when a clock shows 3 o'clock, 3 o'clock means, so here hour's hand will be pointing like this, 3 o'clock, this one, and minutes hand will be pointing 12. Minutes hand will be what do you call it, thin one relatively compared to the hour's needle, and this is pointing this. So this is how the needles, minutes hand and hours hand, or hours minutes needle and hours needle looks like when the clock is showing 3 o'clock. That means the angle between these two needles is, because they are perpendicular to one another, angle between them is 90 degrees. What is that? 90 degrees. So if in radian, pi by 2 radian. Then what is the question here? Then how much angle do its minutes hand and hours needle makes? What is that? 90 degrees or pi by 2 radian. That's it. 90 degree or pi by 2 radian. Pi by 2 radian. That's it. Okay, so and one more thing here, you have to remember that if this angle between these two needles is 90, but if the time is 3 o'clock 5 minutes, in that such case, what is the angle between those two needles? If that is the question, yeah, so you can write down that also. This is very simple, but if that kind of questions comes, you have to remember one more additional point here. So for that purpose, write down one more additional question here. So write down, I am giving directly, if the clock shows 3 o'clock 5 minutes, if the clock shows if the clock shows 3, you can say, you can take like this also, 3.505 or 3 o'clock 3 o'clock 5 minutes 5 minutes or 3 dot dot 05 hours. Both are same only, right? 3 o'clock 5 minutes. Okay, and either way, if it is mentioned the time, then how much angle do its minutes hand and hours hand makes, or what is the angle between the minutes hand and hours hand? Then what is the angle between what is the angle between minutes hand minutes and hours hand or needles? Now, so again you can redraw this diagram. Yeah, this is okay, wall clock, circular in shape. So they can mark 12, 3, 6, 9. So here this is hours hand and minutes hand. You had to mark 1, 2, 5 minutes means the minutes hand will be like here. Minutes hand will be here. Hours hand will be this. Okay, right. Now, so so then what is the angle between these two needles is the question. Theta. You have to remember that the angle between, in the previous case, the angle between the minutes hand and hours hand is 90. So but if you divide this into this, how many parts? 1 2 3 parts. The angle subtending by 3 arcs here is 19. So equally you have to divide, but equally it will be divided. Equally means equally it is divided into 3 parts. So 90 by 3 is equal to 30. From this we have to say, if you draw one small line here, one small line here, the angle subtending by this arc, and this arc, 3 arcs will be that means one quadrant can be divided into 3 equal arcs or 3 arcs of equal length. So angle subtending by each arc is nothing but what is 90 by 30 degrees. So angle subtending by each arc is 30 degrees. So now when this needle is here, you can say this arc, yeah, you see here, this arc and this arc only subtending angles here. This arc subtends 30, this arc subtends 30. So the total angle subtending by these two arcs is nothing but angle between these two needles. That is how you have to understand this kind of questions. Okay, now so it is 30 plus 30 60. That's it. That's how this, right? Directly I'm giving you the answer. You have to analyze this and remember, keep these points in mind. So what is your answer now? Yeah, so it is, so you can say 90 by 3 is equal to 30. Each arc length represents equal angle. Therefore here when the time is 3 o'clock 5 minutes, two arcs of equal length are subtending the angle, that is 30 plus 30 60 degrees. 60 degrees is equal to pi by radian, pi by 3 radian. That's it. Right, next we will see one of the very important concept in trigonometry, that is the trigonometrical ratios. Now write down the subheading trigonometrical ratios. Trigonometrical ratios. Trigonometrical ratios, we can also call them in short as T ratios. T ratios. Right. So here, to understand this concept of trigonometrical ratios, let me give you what is this is Cartesian coordinate system representation. So let us say let me consider this is a horizontal line and one more line, a vertical line, and let me mark this as x O. The point of intersection is O, and this is x dash, and this as y O. Y dash is another straight line. These two lines are perpendicular to each other, so you can say the angle between them is 90 degrees. Okay, and these two lines are intersecting perpendicularly or orthogonally or at right angles. Anyway, you can consider. Now let us, in this case, let us consider the point O as origin, and x dash O x forms the x-axis, horizontal x-axis. Then y O y dash forms a y-axis. Okay. In this case, if you consider one line, movable line or rotatable line, right? Consider a rotatable line or revolving line. So let us say this is a line, this is O and this end is P. So we have moved from here to somewhere, so that this is the line, the other end of the line is marked as P. With an arrow, let us mark it. Okay. So now when the line is rotated from x-axis to somewhere in this space, we call it as quadrant, and at a particular position, at an arbitrary time, the angle made by this with the x-axis is theta. Yeah, under that condition, if you draw a perpendicular from P on x-axis, and if you mark this as M, then this is a perpendicular line, so the angle between this and x-axis will be 90 degrees, obviously. Okay, then in here, now we can say OMP or OPM forms a right angle triangle. When this line is rotating, the angle theta will be changing, increasing. Okay, these points you have to just keep in mind now. Now, to understand trigonometric ratios, here we have to just a few simple terminology you have to remember, guys. In this triangle, we have to say the side which is opposite to the angle theta, this one, that is PM, will be called as opposite side, and the side which is opposite to the right angle 90, that is OP side, will be called as hypotenuse, and the side OM with which the line OP is making an angle theta is called adjacent side. So here we will get three sides of triangle for triangle OMP or OPM, either way can pronounce. For triangle OMP, OM is adjacent side, and OP hypotenuse, and PM or MP is opposite side. So the side opposite to the angle theta is called opposite side. The side adjacent to that angle theta is called adjacent side. Okay. So this way also you can remember. Now, in this, here again, just if you observe carefully, this XOY will give you one quadrant of the entire what do you call the circle. If you compare with the circle, this gives one quadrant. This entire thing is one quadrant. This is one quadrant. This is one quadrant. This is another quadrant. So if you consider this entire thing is a circle kind of structure. So here XOY, where the angle theta will be less than 90, will be called as first quadrant. So you can redraw once again here, and you can compare with the circular structure also. You can compare with circular structure also by considering the diameters. Okay, you see here XOY means this quadrant. XOY, there XOY is first quadrant, first quadrant, first quadrant. And then YO, this is X dash, XO X dash, YO Y dash, right? So XOY is called first quadrant, then YO X dash, YO X dash is called second quadrant. Quadrant spelling is QUADRANT, quadrant. And then there is that YO X dash, this one. Okay, YO X dash is second quadrant. Then X dash O Y dash, X dash O Y dash is called third quadrant, third quadrant. And then Y dash OX, Y dash OX is called fourth quadrant, fourth quadrant. So this is how we can consider quadrants. This is the first quadrant, this is called the second quadrant, this is called third quadrant, this is called fourth quadrant, fourth quadrant, right? Now in trigonometry, how to relate this, you have to remember that this here, if you see in this diagram, obviously this is first quadrant, second quadrant, third quadrant, this is fourth quadrant. Here triangle OPM or OMP, this, the triangle will have three sides. The three sides of this right angle triangle are connected each other with six different trigonometric ratios. Six different ratios, we call them as trigonometric ratios. So how, let us see here. Now actually that we are entering into the concept of trigonometric ratios. Sin theta, can for understanding purpose here itself we can draw this this again, once again, this is X O X dash, Y O Y dash. So here this is O P and this is M and this is theta. Now OMP or OPM is right angle triangle. Now we can say the angle, the side opposite to this angle is called opposite side. The one which is adjacent to is called as adjacent side. The other side is other side. OP is called hypotenuse. So for this, sin theta will be taken as opposite side by hypotenuse. Opposite side by hypotenuse. Hypotenuse. In terms of the symbols, you can write it as opposite side is MP. MP by hypotenuse is OP. So that way also you can write MP by OP. Whereas cos theta for a triangle is given by adjacent side by hypotenuse. Adjacent side by hypotenuse. It is given by adjacent side is OM. This is adjacent side, right? Adjacent side by hypotenuse is OP. OP, right? That is cos theta. Sometimes adjacent side will be called as base of the triangle, and opposite side will be called as perpendicular of the triangle also you can call. So this terminology you have to keep in mind, guys. The next, tan theta. Tan theta is equal to opposite side by adjacent side. Opposite side by adjacent side. Adjacent side. So you can also call this as it is nothing but ratio of sin theta and cos theta. Sin theta by cos theta. So that in turn gives opposite side by adjacent side means MP or PM. MP by adjacent side is OM. MP by OM is tan theta. Right. So this is how the first three trigonometric ratios you can get, and then you have to just simply remember that reciprocal of sin, reciprocal of cos, reciprocal of tan. Reciprocal of sin is Reciprocal of sine is cosecant. So here it simply you can say cosecant. Cosecant theta can also simply you can write it as CSC theta. Cosecant theta is nothing but reciprocal of sine theta. So sine theta is opposite side by hypotenuse. Reciprocal of this is means hypotenuse by opposite side. Opposite side. Then another one is secant theta. Secant theta is secant theta. Sec theta I have to write. Okay. Secant theta can be considered as reciprocal of cos theta. 1 by cos theta. So 1 by cos theta. So this is equal to cos theta is adjacent side by hypotenuse. So it is a hypotenuse by adjacent side. Adjacent side. So this is how you can take secant theta. The next one is cot theta. Cot theta is cotangent theta. Simply we call this as cot theta is reciprocal of tan theta. Reciprocal of tan theta. It is given by tan theta is opposite side by adjacent side. So this will be cot theta will be adjacent side by opposite side. By opposite side. This is how the three sides of a triangle are related with the six different trigonometric ratios. Six different trigonometric ratios. So here you have to remember cosecant theta, secant theta, cot theta, how they relate with sin theta, cos theta, and tan theta. Sin theta, cos theta, tan theta will be like the primary ones. Primary trigonometric ratios you have to consider. If you know them, then the remaining ratios you can write them easily while doing the numericals, while dealing with the questions. Not exactly numerical, while dealing with the questions. So here we have to remember few basic trigonometric ratios also. I can write down as a heading basic trigonometric identities. So a few basic trigonometric identities. Basic trigonometric identities. Yes, only just three identities. Just I will give you here. Those are the first one is sin square theta plus cos square theta. Sin square theta plus cos square theta is equal to 1. By using these different ways, you can write. Okay, and second one is 1 plus tan square theta. 1 plus tan square theta is equal to secant square theta. And third one, 1 plus cot square theta is equal to cosecant square theta. Cosecant square theta. Right? These three trigonometric trigonometric identities, we will use a number of times in physics. Out of this, the first one so frequently we use in physics. So frequently, number of times in different number of chapters we use sin square theta plus cos square theta equal to 1 relation. Okay. Now, so related to this, let us try to work out one simple numerical. Then we will discuss some standard trigonometric ratios also. Okay, first we will see the few standard trigonometric ratios, then we will discuss few questions. So let us see, note a subheading, the trigonometric ratios of few standard angles. Write down trigonometric ratios of trigonometric ratios of a few trigonometric ratios of a few standard angles. Few standard angles. Standard angles usually consider, you can within bracket also you can write 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Here one more I'll add 53 degree also is one of the 37 and 53 degree and 37 degree. So these are also standard angles. So all together we call them as standard angles. So what are the values, trigonometric ratios or values of trigonometric ratios for these standard angles? So let us in the form of a table, let us write these values so that you guys can remember easily. So write down here Let me insert a table. Oh, 2, 3, 4, 5. And let us take a table this much. Yeah. Okay. So here, let us consider the function sine for the function, the angle theta. So here consider the sine function, sine theta, cos theta, tan theta. Only these three. The reciprocals of these we can consider as sine reciprocal is cosecant, cos reciprocal is secant, and reciprocal is cot. You can get those reciprocal values automatically if you remember this. Now first, theta, if you take it as 0, 30, 45, 60, 90, then 37, 53. 37, 53. Right, first 0. Sine 0 is 0. You have to remember this values. Okay. Now cos 0 is 1. Tan 0 is 0. Because tan theta equal to sin theta by cos theta. 0 by 1 is 0. Then sine 30. Sine 30 is 1 by 2. Cos 30 is root 3 by 2. Root 3 by 2. Tan 30 is sin theta by cos theta. That is 1 by 2 by root 3 by 2. 2 to cancel, you will get 1 by root 3. Right. 1 by root 3. And 45, sin 45, 1 by root 2, cos 45 also 1 by root 2, tan theta is sin theta by cos theta, so 1 by root 2 by 1 by root 2 cancel, you'll get 1. So tan theta is tan 45 is 1. Then yeah, then 60, sin 60, actually 30 and 60 are complementary angles, so sin and cos values will interchange for this. So you have to say sin 60 is nothing but cos 30, so that is root 3 by 2. And cos 60 is nothing but sin 30, it is nothing but 1 by 2. And tan 60, the ratio of this, so root 3 by 2 by 1 by 2, 2 to cancel, you will get root 3. Then sin 90 is 1, cos 90 is 0, tan 90 is sin by cos, so 1. Right. So sin by tan 90, is it 1? Sin 90 is 1, cos 90 is 0, tan theta is 1 by 0. Anything by 0 is it 1? Have to be careful. So 1 by 0, usually you can write infinity, but actually speaking it is undetermined. Some books will give you it as infinity, but you have to consider this as not defined or undetermined. Not defined or undetermined, I have to mention. And 37, 43, 53, these two are little special angles. To understand this, I'll give you specifically one table here, one with the help of a triangle. Let us consider this triangle. This is 37, this is 90, and of course then this will be 53 degrees. This is 90, 53. Okay. So whenever you consider this side, start from 53. This is 5, this is 3. This side let us mark this as 5, this side as 3. Then by applying Pythagoras theorem, you have to say according to Pythagoras theorem, hypotenuse square equal to side square plus side square. So from this you will get this is 4. Hypotenuse square is equal to side square plus side square. So here this is 5 hypotenuse, this is 3, then 5 square is equal to 3 square plus this unknown value, you can take it as x, some x, so then you'll get this side as 4. So that is how you can get by using Pythagoras theorem, this one. So now if you, 3 sides are known, this is called as a triplet, 3, 4, 5. For this, now just by using the trigonometric ratios, sin theta, here in the place of theta if you consider 37, sin 37, Sin 37, cos 37 and tan 37. Similarly for 53 angle also you can consider. Okay, what is that? Sin 53. Okay. Oh, wait, something happened here. Yeah, actually, in physics, the standard angles 37 and 53 will be used so frequently than other angles, especially while dealing with a little higher level questions. 30, 45, 60, 90, these standard angles will be of course used so frequently, but specifically while doing little higher level questions, these standard angles 37, 53 will be used so frequently, right? So let us say sin 37, cos 37 and tan 37. How to get? Then sin 53, here only you can take sin 53 and cos 53 and tan 53 degrees. So from this triangle, if you look at the triangle, you can get this value so easily that you can remember. Okay, so from the triangle, sin 37, sin theta is opposite side by hypotenuse, so 3 by 5. Sin 37 is 3 by 5. Cos 37, cos theta is adjacent side by hypotenuse, 4 by 5. Tan theta is opposite side by adjacent side, 3 by 4. Then sin 53. So this is the 53 angle. As according to this angle, this is the angle. Sin theta will be opposite side by hypotenuse. For this angle, this is opposite side. For 37, this is opposite side. Okay. For 53, 4 is opposite side. So opposite side by hypotenuse, 4 by 5. 4 by 5. You can also call this 37 and 53 are complementary angles. So sin and cos values will interchanges. So sin 53 is 44 by 5 here, and cos 53 will be adjacent side by hypotenuse 3 by 5. So you check here. Cos 37 is nothing but sin 53, 4 by 5, 4 by 5. And sin 37 is cos 53, 3 by 5, 3 by 5. So these are called complementary angles. Then tan 37 is 3 by 4. Here tan 53 is opposite side by, what do you call, adjacent side, 4 by 3. For 53, 4 is opposite side, 4 by 3. So this is how you can remember these standard angles called 37 and 53 values of different trigonometric ratios. Then another very important point is how to remember the sign convention of different trigonometric ratios in different four quadrants. For remembering the sign conventions, we have to remember one rule called ASTC rule. So four quadrants and ASTC rule. Let us see how that rule will helps in remembering the sign conventions of different trigonometric ratios in different quadrants. So write down next subheading. ASTC rule. ASTC rule. ASTC rule. Yeah, for understanding that, again let us draw the Cartesian coordinate system with the XY axis only, not complete XYZ axis. But instead of using the word Cartesian coordinate system, let us consider horizontal and vertical axis. Horizontal and vertical axis. So let us say this is horizon, and let us say this starting point makes is considered as a 0 degree. Then if you treat this is a part of a circle, this will be taken as one quadrant. So this will be 90 degree or pi by 2 radian. Okay, so angle between these two is nothing but this angle. Then if travel from here to here, then this angle will be taken as plus 90 degrees. When you cover 90 degree, then you will end up on this line. If you mark this as xo x dash y y dash kind of, so this then 90 plus 90 is 180. So this can be expressed as 180 degree or pi radians. Then similarly, this line, as if you travel 90 more degrees, you'll get this as 90 degrees plus 90 degrees will give you this. So 180 plus 90 is 270 degrees, or I can say pi plus pi by 2 is 3 pi by 2 radians. 3 pi by 2 radians. Then if you travel 90 more degrees, we end up with 270 plus 90 gives you 360 degrees, or 2 pi radians. 3 pi by 2 plus pi by 2 will give you 2 pi radians. So in radians, 0 radians only can take 0 degrees, 0 radians. Then pi by 2 radians, pi radians, 3 pi by 2 radians, 2 pi radians. In terms of degrees, 0, 90, 180, 270, 360. This is how this will represent actually a circle. This is nothing but a circle. It's nothing but a circle. So the entire total angle subtending at the center of a circle is 360 degree. Okay, so you can draw this even little more properly. See here with more clarity. This total angle subtending by the circle of the center is 360 degrees. Right. So in this, if you mark this is as already we have discussed, x o x dash, and this is y o y dash. So here x o y gives first quadrant. So you can call this as first quadrant. Here you have to remember that all trigonometric functions are positive. All trigonometric functions in first quadrant are positive, whereas in the second quadrant, this is called second quadrant. Draw this properly, guys. Everyone draw this. So try to take a paper and draw this properly and remember the points. So this is called second quadrant. In second quadrant, only sine function and its reciprocal called cosecant will be positive. So we will remember sine. Here the first letter you have to remember is S. Okay, let me write this a little more clearly for remembrance purpose. Yeah, so here this is all. Here you have to remember A. Here this is sine. So here first letter is S. Then here tan. So here we have to consider the T, and here in cos, first letter of cos is C. These are positive. So this is second quadrant. Then I can mark this as a third quadrant. Yeah. So this is second quadrant, third quadrant, and this is fourth quadrant. In first quadrant, all trigonometric functions are positive. In second quadrant, only sine function and its reciprocal cosecant is positive. Okay, and in third quadrant, tan function and its reciprocal cot function is positive. In fourth quadrant, cos function and its reciprocal secant are positive. So this we have to remember. So if the first letters, if you consider all A, sine first letter S, tan first letter T, cos first letter C. So A S T C. So this is for remembering purpose. We are taking it as A S T C rule. So for the purpose of remembrance, we can expand these, or we will give as a mnemonic as all silver teacups. All silver tea cups. All silver teacups. So first letter C A S T C. In this way you can remember. For remembrance purpose, we can call ASTC an expansion form as all silver teacups. So in this, here stands for all. In first quadrant, all trigonometric ratios are positive. S stands for sine. So in second quadrant, sine is positive and its reciprocal is positive. In third quadrant, T stands for tan. Tan is positive and its reciprocal cot is positive. Then C stands for cos, and so in fourth quadrant, cos and its reciprocal secant are positive. So these points just you have to note down and remember. Here just we give more clearly, note down this. In first quadrant, comma, write down clearly, all trigonometric ratios are positive. All trigonometric, all trigonometric ratios are positive. Next, in second quadrant, in second second quadrant, comma, sine theta and its reciprocal cosecant theta are positive, means the remaining functions are negative. Cos is negative, its reciprocal secant is negative, tan is negative, cot is negative, all other remaining functions are negative. And in third quadrant, yeah, from the ASTC rule, tan theta and its reciprocal cot theta are positive. The remaining functions sin, cos, their reciprocals are negative. And then in fourth quadrant, in fourth quadrant, cos theta and its reciprocal secant theta are positive. That means other remaining functions, means sine, cosecant, tan, cot are negative. So these points you have to remember. So you can also, some books may give you some other ways of remembering for remembering purpose. Instead of all silver teacups, add sugar to coffee, or after school to college. This kind of expansion sentences also will be given. Just by using any of these you can remember. ASTC rule. ASTC rule. In ASTC, this A stands for all, S stands for sine, T stands for tan, C stands for cos. Right. Next, next, another very important what do you call set of conditions is the trigonometric ratios of general angles. This is also very important in handling the questions related to trigonometric ratios. So write down. We also call them as a reduction formulae. So sin pi plus theta becomes what? Sin pi by 2 theta, sin pi by 2 plus theta becomes what? Sin pi by 2 minus theta becomes what? This kind of relations to handle with. To remember, you have to remember the conditions which we are discussing now. So write down as a subheading for this purpose: trigonometrical ratios of general angles. Trigonometric ratios of general angles. Trigonometric ratios of general angles. Trigonometric ratios of general angles. Yes, guys. Yeah, all this you might have studied these basic points in your lower classes. In detail, you may discuss. You may study this in the 12th standard. So already those who are already in 12th standard, completed 12th standard, you should know all this. So as a recapitulation purpose, you can go through this quickly. Right. See here. First point. The trigonometric function of angle 2n pi plus theta will remain same. The trigonometric function of this angle. The trigonometric ratio can be any: sine, cos, tan, any. So sine of this, cos of this, tan of this, any, remains same, provided here n is an integer. It can take the values 0, 1, 2, 3 and so on. For any value of n, the trigonometric function of this angle will remain same. So you can write in a proper word, in a proper sentence. Write in a proper sentence. Yeah, I'll write down. Note down. The trigonometric function of an angle. Trigonometric function of an angle. Well, the function can be sine, cos, tan, any function. Okay. Trigonometric function of an angle 2n pi plus theta, where n is equal to 0 comma 1 comma 2 comma 3 so on, will remain same, will remains same. What does that mean? Let's see here. If the function is sine function, that means if we take sine of 2n pi plus theta, that remains same, means sine function will remain same as sine only, will get sine only. So 2n pi plus theta will give you sine theta, sine theta. Similarly, cos 2n pi plus theta gives you cos theta only. The value of n can be any value. Say if it is n equal to 1, so 2 pi sine 2 pi plus theta, 2, 4 pi plus theta, 6 pi plus theta, 2, 3 and so on. If you give any values to n, then you will get, if it is 0, 0 plus theta is 0, theta, so sin theta. Then if it is n equal to 1, 2, 3 and so on, then you will get 2 pi plus theta, 3 pi, 4 pi plus theta, 6 pi plus theta. Any of these angles will give you the same function. Similarly, we can take tan 2n pi plus theta is equal to same function, tan theta only. So reciprocals of these, the cosecant, secant, cot, if you consider, if you apply these angles for any those functions also, you get the same functions. That is the meaning of it. So you have to remember this. That means you can also here you can take for n is equal to 1 sine 2 pi plus theta. That means 2 pi is 360 degrees. You can also take in terms of degrees, 360 plus theta is sine theta. And if it is n is 2, 2 into 2, 4, then sine 4 pi plus theta is sine theta. So in this diagram, if you observe here, sine 2 pi plus theta means after completing one rotation. So 2 pi plus theta comes in first quadrant. First quadrant all are positive and function will not change, remains same. So same function will get with positive sign. That is also important. Sign convention is also important. The function remains same with positive sign. Okay. Likewise, that is sine 2 pi plus theta, 4 pi plus theta, 6 pi plus theta. Here in this case, if we give any value, you will get even numbers only. 1, 2 pi, 2, 4 pi, 3, 6 pi. Like even pi's only will get 2 pi, 4 pi, 6 pi, like that. Right. So you have to remember this. Next one is second one. So here write down trigonometric function of an angle. Trigonometric function of an angle. Trigonometric function of angle or of an angle n pi by 2 plus theta. N pi by 2 plus theta. N pi by 2 plus theta will remain same. Remains same if n is even. If n is equal to even, and sine, this is very important, and the sine of trigonometric function and sine of trigonometric function will be sine of trigonometric function will be according to the value of that function in the quadrant. According to the value of that function in the quadrant, in that quadrant, or in the quadrant. What does that mean specifically? We'll see here. If n is even means n equal to 2, 4, 6 and so on, then 2 means 2 by 2 cancel, you'll get pi plus theta. 4, 2 pi plus theta. Yes. So whatever it is, if you observe like this, pi plus theta, 2 pi plus theta, these kind of values, if you come across, the function remains same, but sign Sine will be according to the value of the function the quadrant. In which quadrant you come across, according to the ASTC rule, the sign will be applicable. According to ASTC rule, sign will be applicable. Let us consider few functions here. If n is equal to 2, then sine pi plus theta you will get. Sine pi plus theta you will get. Pi plus theta comes in which quadrant? If you just consider this, this is 0, pi by 2, pi 3 pi by 2. So here the first quadrant can be considered as pi by 2 minus theta. Second quadrant will be considered as pi by 2 plus theta. Similarly, in terms of pi, pi minus theta comes in second quadrant, pi plus theta comes in third quadrant. Similarly, 3 pi by 2 minus theta comes in third quadrant, 3 pi by 2 plus theta comes in fourth quadrant. This is the first, second, third, fourth, and 3 pi by 2 plus theta comes in fourth quadrant, and you can say this is theta or 360. 360 minus theta comes in, or 360 means 2 pi radians. 2 pi minus theta comes in fourth quadrant. So this, if you have some idea, it is okay. Otherwise, you have to note down step by step. Then only you will understand and you can follow. Okay, now sine pi plus theta, pi minus theta comes in second quadrant. You can draw a little bigger diagram, otherwise you may confuse. First, second, third, fourth. Right, 0, pi by 2, pi 3 pi by 2, and here at the point of 0 only you will get 2 pi also. Now pi plus theta comes in third quadrant. So pi plus theta here, according to ASTC rule, ASTC rule, pi plus theta comes in third quadrant. There tan is positive and its reciprocal is positive. The remaining functions are negative. So sine in this tan and reciprocal are tan and cot. What about sine is negative, so it is equal to, immediately have to put negative sign. Pi plus theta comes in third quadrant sine is negative, so negative sign. So but according to this rule, pi plus theta remains the same function, so sine theta only here, so minus sine theta. That is how you have to take it. Sine pi plus theta is minus sine theta, whereas sine pi minus theta, so pi minus theta comes in second quadrant. So in second quadrant, sine is positive, so give the sign first. So positive, which one? Sine. This function you have to look at. So sine is positive here, then pi minus theta remains same as sine only, so plus sine theta. Right. Similarly, you can consider some different other functions also. Cos. Let us say cos pi plus theta. Pi plus theta comes in third quadrant. In third quadrant, tan and cot only positive. Cos is negative, so minus. Cos pi plus theta is minus. Function remains same, minus cos theta. Then cos pi minus theta. Cos pi minus theta also comes in second quadrant. In second quadrant, sine and its reciprocal cosecant are positive, but cos is a negative, so minus. Again, this is here. Cos pi minus theta also negative. Cos pi plus theta is negative, and cos pi minus theta also negative. So these points you have to be carefully follow. So okay, so this is how we can follow this ASTC rule and some of these rules to find the functions and their sign conventions. Okay, and if n is even, this is how you have to come across. But if n is odd, like n is equal to 1, 2, 1, 3, 5 and so on, 1 pi by 2, 3 pi by 2 and so on, then function changes and sign will be taken according to the quadrant. This is another very important point. Note down this. So if trigonometric function of n pi by 2 plus theta will be changed to co-function. This is very important. Will be changed to co-function. Reciprocal functions means what is that? You have to be careful. Sine co-function is cos co-function is sine. Tan co-function and reciprocal both are cot only. Okay, you have to be careful about this. The change will be changed to cofunction if n is equal to odd. This is very important. Okay, and sine of the function, trigonometric function, sine of the function will be sine of the function will be according to the value in quadrant the according to the value of the function or that function in that quadrant, in the quadrant or in quadrant. So example, let us see here, sine pi by 2 plus theta. Example, see here. So again you can draw this 0, pi by 2, pi, 3 pi by 2, 2 pi. So here if n is odd, n that is in 2n pi by 2 place, if you keep a 1, then pi by 2 plus theta will get. So pi by 2 plus theta is this is first quadrant, this is second quadrant. So pi by 2 plus theta comes in second quadrant according to ASTC rule, ASTC. So here sine and reciprocal of this cosecant are positive, but sine here in the second quadrant. So sine pi by 2 plus theta comes in second quadrant, and second quadrant sine is positive, so put plus sine. So function changes to cofunction, guys. Sine, cofunction of sine is cos, so cos theta. This point you have to carefully remember. Similarly, cos pi by 2 plus theta is equal to, so cos pi by 2 plus theta comes in second quadrant. In second quadrant sine and cosecant are positive, but cos is negative, so first sine, then cos changes to its cofunction sine. Got it? So like this you have to mention. Then sine pi by 2 minus theta, cos pi by 2 minus theta, sine pi by 2 minus theta. Pi by 2 minus theta comes in first quadrant. Here all are positive, so plus, and sine changes to cos, so plus cos theta. Whereas cos pi by 2 minus theta, cos pi by 2 minus theta, pi by 2 minus theta comes in first quadrant. First quadrant all are positive, and the cofunction of cos is sine, so plus sine theta. What about tan and cot? We take tan pi by 2 minus theta. Pi by 2 minus theta comes in first quadrant all are positive. Cofunction of tan is cot theta, so we have to take it as cot theta. Got it? Whereas tan pi by 2 plus theta, pi by 2 plus theta comes in second quadrant only tan and its reciprocal are positive, so tan is negative, so minus. So tan will changes to its cofunction cot theta, minus cot theta. So this is how you have to take the signs wise. So yeah, here just I would like to wind up now. So there are a few more points are there. I thought to just wind up so quickly. Those some few important trigonometric formulae like sin a plus b cos a plus b tan a plus b sin 2a or sin 2 theta cos theta formula, and some related points just we may discuss with few examples in the next session. Okay, now just I'm winding now. You guys go through this and note down, copy it down.